fiction into fact.
Sometimes kind of real architectural life interferes with intellectual architectural life.
There is no such thing as architecture.
Hello everyone, this is Vikram Prakash and you are listening to Architecture Talk. We are currently in the middle of our special series, Architecture in the Time of Coronavirus. And today, in the second of our presentations in this series, I have a fascinating conversation here for you with the fantastic scholar Rachel Armstrong from the University of Newcastle in the United Kingdom. She has just come out with a book entitled Experimental Architecture, and she has a fascinating take on what a future architecture might be, including an amazing and interesting reading of how one can think about or rethink the purposes of sustainable thinking through the lens of coronavirus. Look out for the portion on probiotic architecture. Here we go. I hope you enjoy. So let me begin by first thanking you for coming on to this podcast and welcome you to Architecture Talk, Rachel.
Well, thank you for inviting me onto the podcast.
I'm very energized to have this conversation when I look at all the material that you have online, when I listen to your fantastic TED Talk, and as I read more and more about the Living Architecture Systems Group and your concept of metabolism and living architecture in there. As we go through this conversation, I'm looking forward to learn more about what you think is the frontier of architecture. And it's clear to me that you advance the frontier. So very excited about that, but hopefully we can also talk about the implications of the coronavirus and how that as a living system possibly impacts your thinking and your thinking about what architecture might be. So by way of introduction, I thought I would read a little quotation from the abstract of your new book, Experimental Architecture Designing the Unknown. And I love that title already, Experimental and Unknown. Two happy words for me. So here we go. Experimental architecture's explorations are predicted on shifting away from the traditional view of architecture as a static form giving subject to protocols for choreographing space through worlding. Fantastic phrasing. Choreographing space through worlding, which invites alternative modes of inhabitation and being in the world. So, inviting us to think of other ways of living and being in the world. Knowledge fields are developed through storytelling as a transdisciplinary synthesis, storytelling, which becomes key not only to developing the scope of research itself, but also in its capacity to link and connect forms of expertise previously kept apart. So, link and connect forms of knowledges. So, this sounds like you're hinting at something more than interdisciplinary and transdisciplinary thinking. So, that'll be interesting. And then it says characteristically experiments speak to transformative materialities that conjure invisible realms, embrace change, provoke uncertainty, take risks, create hybrids, and are formed from hyper complex materials like fur, soil, and felt. So that's an amazing and extremely provocative introduction. And you further go on to say that the kind of visions that you're establishing share more with surrealism than anything else, and that ultimately, or sorry, I suppose fundamentally and constitutively, uh, you are or you're thinking about inhabitation of living spaces and the notion of what constitutes therefore a body. So this is heady stuff, Rachel, and sounds very well futurish, as you say in your own introduction. It's very future oriented. So living things, and from your TED talk. So let's first introduce basically what is your conception of living architecture. And let me start by asking you if you have heard of those bridges in I think they are in
Cherrapunji.
Burma, yeah, which are made out of trees. Yes, is it
Yes,
true?
yes,
Yes,
yes, the living root bridges. Yes,
yeah, living bridges. How would you differentiate and connect your work with those bridges?
I would say that the practice of experimental architecture through living architecture is embracing a paradigm that's emerging already, both within the field of design and architecture, but in society more widely. And that paradigm shift is the transition from an industrial era of thought and design towards an emerging ecological era. Now, the nature of that ecological era is not defined. And so it necessarily invites an experimental approach. And what living architecture does within that realm is literally to embody the processes of life as the form of experiment, as the context and, let's say, ethical and environmental framework in which the experiments in design and space and matter can take place. In other words, we stand inside a system and start to embody life itself. So, the quote that you read from the Introduction to Experimental Architecture, in some ways as well, is embracing a language for design and architecture that helps articulate some of the transitions that are being attempted in the process of design. And so it doesn't try to mimic the living world, it tries to embrace the forces, the materials, the vibrancy that is peculiar to our world. And so I would say that something like the living root bridges are absolutely in keeping with a living architecture. It would be desirable if the kinds of materials we designed and the technologies that we used could actually have the smartness and the highly contextualized and situated qualities that roots have. But in terms of our technologies, we're still mainly working with an industrial toolset. And so the living architecture term itself came out of work that was being done at the turn of the millennium in a group of scientists that were starting to look at this idea of living technology, which was acknowledging that in the late 20th century, I guess it's also very similar to what Donna Haraway was saying in her Cyborg Manifesto, that, you know, we ourselves were becoming increasingly inert whilst our technologies were becoming increasingly lively. And so the scientists were looking at lifelike technologies. So that ranged from the internet to robots that cared for the elderly to protocells, these call it soft, smart materials that could navigate spaces and produce form in the process.
That you work with quite a lot, the protocells, right?
That's right. Yeah. So I started to experiment with some of the manifestations of living technologies, but rather than using biomimicry, rather than trying to copy nature as, let's call it, an end state, I was using the origin of life sciences as the navigational system through which the living technologies could be articulated through design. So that was, I guess, the first move that I wanted to make. So I trained and practiced as a doctor, and one of my special fields of interest was biochemistry, and that was where I came across this wonderful in-between landscape of organic matter that had kind of embodied intelligence in itself, like proteins, and inorganic matter that through, let's call it crystal formation, also had a kind of program, and that the body managed to bring all this incredible material stuff together. And these scientists were starting to choreograph that in different ways. And so it was an incredible...
Why do you specifically use the term choreograph from dance?
Right, choreography as a one, to acknowledge the agency of the technologies and the materials that I aim to engage with, so that it is not simply a system of control and subordination. And so it kind of recognizes the inner life of a system, but also figures out the relations between the actors within a system. And so it starts to take that first step into a non-industrial arena. So I would say that choreography is one of those terms that starts to become compatible with ecological thinking.
It sort of recognizes a limited alterity or otherness to the material.
That's right.
Rather than seeing it as completely inert and subservient. I see.
Right, exactly. So design is actually negotiated, and in that way as well, it is quite difficult to try to take steps back from anthropocentrism and try to look at common or shared goals, even with agents that are not human. So how do we design in a world that is more than human is really the question at the heart of this. And finding the right palette of tools and portfolio of design techniques to try and engage with some of those questions is at the heart of the quest.
So would you identify your project as decidedly post-humanist in the sort of Donna Haraway, Karen Barad, or whoever tradition?
I would be reluctant to say post-humanist. I would like to say it is the expanded human. And why do I say that? Partly because I have come from medicine and I have got my PhD in architecture, and that both of those disciplines are human-centric. So there is a strong core of humanism both in those disciplines. And I am very wary that to step into the post-human, one could lose the status of humans in the world, and to try and render them not important, or to get rid of humans, or somehow or other negate the contributions that our species has made. And I don't want to look at humanity negatively. And so I like this idea of a more than human, or an expanded human interest in the work that I'm doing. And also, I think a certain humility in the sense that I cannot sidestep my humanness within the work that I'm doing, although the attempt to climb inside the skin of something that isn't me and something that isn't human is certainly at the core of what I'm doing, because to find the empathy and, Spoybrook's sympathy with things, I think is really part of the ethical concerns that come with a more than human realm and an ecological approach.
Right. So, but certainly an ecological approach, and I guess would you say a non-anthropocentric though?
I would like to try to, yes, de-anthropocentrize, admitting that right from the outset, I cannot stop being human. I cannot, to design by definition is to invite in its current state a human presence and contribution to the work. So it's very difficult to see how you could actually totally stand outside that. Although with the work with the protocells, the process through which the chemical agents navigated their space did produce forms of design, kind of soft sculptural forms that may not have appealed so much to the human presence, but were certainly the result of complex negotiations between these agents. So trying to take as many steps back as possible to see what matter does, I think, is part of that. And again, I think it is a certain humility that one approaches this with in terms of design, and kind of understanding that at the end of the day, you are making aesthetic or functional judgments or using instruments and technologies that are coming from an industrial era, the very one that you propose that you're trying to escape. This idea of non-innocence, the acknowledgement of your status within an experiment, within design, is not at the apex of a pyramid, but is kind of complicated and entangled with all kinds of other things that are going on.
Right. I think that's great. Well, I think at this point, it might be great if you describe for us your favorite experimental architectural project. What are you working on?
Well, the project that I've just finished, which was a collaboration with 6 European institutions, so University of the West of England, University of Trento, Spanish National Research Council, Liquid for Systems Group, Explora Biotech, and Newcastle University, was a prototype for a metabolic infrastructure for a home. And so that was actually called Living Architecture, and it was funded by the European Union to a sum of 3.2 million euro. And essentially what it did was it programmed with metabolism. In other words, it set up building blocks or bricks that had an inner life, and these inner life forms were conducted by microbes. So there was one form of brick that was a microbial fuel cell. What that is an organic battery that uses anaerobic bacteria, so the kinds of microbes that you'd find in compost. And that could process household liquid waste, so urine, wastewater, and turn it into low power electricity, cleaned water, and a range of metabolites. Then that was juxtaposed with a photosynthetic reaction that was conducted by algae, which produced oxygen. So they could fix sunlight and carbon dioxide, and in the process, they produced oxygen. Now, that oxygen was very useful to the microbial fuel cell because it's an end terminal electron acceptor. So, in other words, it pulls the electricity out of the organic cell and makes it stronger. So whilst it's also removing carbon dioxide from air that's coming into the system. So that's being able to produce designed metabolism by juxtaposing 2 natural systems together, and they're separated by a ceramic membrane. So 2 different metabolic worlds can talk to each other through design, so they can process household waste and make, let's say, resources for living. So the kinds of utilities that we would expect in a household. Now, in addition to that, we wanted to see just how far we could design with metabolism. So we used synthetic biology. And based on that natural system, we then created, let's call it a little brick or a tiny house for synthetic organisms. And this was really quite extraordinary, some fantastic work done by the Spanish National Research Council. But the upper floor of this building was it's a tiny building for microbes. It was made of glass, so it let light in, and that light fed modified algae. And those algae just produced loads of sugar. It's like Charlie and the Chocolate Factory for microbes. So when it produced loads of sugar, it could filter through the floor plate, which was a ceramic plate, and then into the darkened basement, where there were what was called workhorse organisms. I don't really like that term because it feels exploitative, but that's the laboratory term. Now, a workhorse organism is a creature whose genetics you know very well indeed. And so you know how you might be able to move those genes around so they can do something new. And so these workhorse organisms were from different species, and they didn't normally live together. But when you gave them the sugar coming from, Charlie and the Chocolate Factory's environment, they would work together. And so not only could we design different metabolisms, so some that could remove phosphate from washing powder, and some that could metabolize nitrous gases, which are pollutants in the air, but we could design that metabolism across different species. So that meant that we greatly expanded the tool set for metabolic design. So that was really quite interesting because it proved a principle that we could develop something that we might call a metabolic app. In other words, programmable building blocks of metabolism or kind of microbes that could take your household waste and selectively process it according to the things that you wanted to reclaim out of it. So the idea, in the long term is to take us off fossil fuels and reconfigure a household system that literally use kitchen waste and wastewater and urine and even human solids as the resources through which we can relive our daily lives.
I see. Fascinating. I can't claim to have completely followed all the technology, but from what I could gather about these living bricks, which I really like, because I'm sure Louis Kahn would be very excited to run into living bricks. But besides that, the idea that these are bricks which both can, metabolize waste and potentially, well, sequester carbon or produce oxygen and produce electricity in part out of that sounds very futuristic, sounds very interesting and exciting. But what I'm trying to get, what I'm not getting, is how is this space design construct rather than a technology which, say, I could attach to my home?
Absolutely. So the spatial design is actually we used the word earlier, which is the choreography of the organisms. So the spatial organization of where the organisms live and how they communicate with each other is much more like a dance or tuning a system than flipping on a button on and off. So the
design is in the design of the microsystem. It's not like you're designing a room with it.
That's right. Yes. So it's more like a systems design or an infrastructure. But if we foreground the microbes as, let's call it, the client or the occupants of the houses that we're making, then that is absolutely a design project, because we have to figure out the spatial dimensions, what materials it's made of, how the flow comes into the brick, the quantities of material it needs, the control systems through which we can regulate this. We also have artificial intelligences that can speak to the microbes in the sense that they can pick up how much electricity they're producing. They measure the flow of electrons, and then they can regulate the microbes' needs through an electromechanical system that kind of expands the notion of, let's call it, interactive design. So we now have, let's call it, a microbial intelligence talking to an artificial intelligence that between them are negotiating flow, space, intensity. So there's a whole set of parameters that get set up through the design process.
Yeah, I like that very much. It's not that you are building houses with this, it's rather that it seems to me that you are applying architectural thinking or architectural intelligence, design intelligence, to producing, to designing and making these metabolic entities, which suggests to me that you're using an expanded definition of what architecture is.
That's absolutely right, yes.
And it also suggests to me that in these kind of systems, there is already a kind of receptivity to architectural thinking, which is rather than something that's purely, let's say, technological. Is that?
I would absolutely agree with you. And over the last, gosh, how many years I've been doing this, I have seen the benefits of design-led research and thinking in cutting-edge technological innovation in teams of designers and scientists, where artists and designers have been at the forefront of the innovation. So, for example, Simone Ferracina, who was a research assistant for the Living Architecture project, and who also is an architect, was designing these bricks with glass rods as a structural system that could accommodate flow. And he was working really closely with the scientists to kind of understand, almost like it was, the building parameters of a living space for microbes that is really the size of a traditional brick. But also, this was necessary for the success of the project, because let's say that the parameters through which you can model it vastly outweigh what you can actually model and create through design. So there was a lot of iterations going from digital model to physical system and back again, in order to help us understand the invisible complexities of actually making something at this scale, and with this level of complexity within it.
Mm-hmm. Fantastic. So, after all this, what is your definition of architecture?
I would keep a very simple definition of architecture, which would be the spatial concerns of matter and material and time, and engage it with design protocols. So it's the designed choreography of matter, space, and time, and I would keep it as fundamental as that. I wouldn't even introduce the humanistic aspects that have come to define the field, even though they are key to my thinking.
Yeah, well, I like that. I mean, in that sense, it's a kind of a post-anthropocentric or post-humanist definition of architecture in that specific way. But let me sort of shift this a little bit. Do you see your work as descendant in some ways of the thinking of people like Buckminster Fuller and that kind of worldview?
I think there's definitely, an ontology of organicism, nature-based solutions, the idea throughout architectural history that both the body and nature are key to good design. So it's not an architectural proposal without any history. What it does do, I think, that is different is it really embraces the 21st century insights that maybe can open up spaces that were not possible for some of the earlier design practices to access. So I'm thinking of even people like, Gordon Pusk and Stafford Beer, in terms of looking at, cybernetics and how if they change the materials within the feedback systems, they were looking for, kind of disruptive forms of design, but molecular biology and chemistry and the late 20th century sciences hadn't happened yet, and so Stafford Beer's experiments with Daphnia never really progressed. But I think if he'd had access to some of the molecular biology, I think he'd have had an absolute riot with it.
All right, so it's kind of so moving this into the 21st century and beyond, I suppose. So you earlier characterized your work as ecological in that sense, and so it's moving from a more My term would have been actually metabolist, 60s, 70s, metabolist, from a
Right.
metabolist to an ecological perspective. But many definitions of the word metabolism. But let's say in the history of architecture, let's say 60s metabolist view to an ecological 21st century view, which is expanded human or recognizes our complex interrelationship with the world. So to zoom out a little bit from the specific work and its kind of utility agency to design and architecture, zooming out, how does this integrate or convert into a theory of living, as you allude to in your introductions of the book? What is its conception of the future, a future ethics of human living in the world?
I think it's fundamentally regenerative. And one of the things that modernity doesn't do is deal with waste as a positive experience. It ships it out and either kind of buries it or doesn't want to talk about it and therefore doesn't deal with it. And therefore, there's no technologies for dealing with it. So that I think the approach is really to embrace the full life cycle of living and dying and the regenerative processes through composts and rebirthing or birthing, that complete that idea of, let's say, circularity, which is a word that's being used a lot at the moment. But I don't see things as really being circular. They're more like corkscrews. There's a slight slippage in every iteration that allows evolution to take place or adaptation, so that it's never quite a complete circle, but you can get repetitions and iterations that in some ways are also computational. So in some ways you could say that that is the way that nature counts, through iterations. So it differs in the sense that it actively engages with the certain things that modernity hasn't dealt with. It doesn't just positively deal with natural systems. It kind of looks at the downsides of them. And, we could talk about the pandemic, because if we think about the expanded human world in a sea of microbes, many of those microbes are working along with our own bodies. So we're almost holobiontic with them, that they are extended organs and skins and presences within our environment that may certainly play a role in our health, but what other kinds of roles they play has not yet been established. And of course, the microbiome of the built environment is now a terrain that is being opened up, certainly by the University of Oregon with people like Jessica Green. And so this idea of the expanded realm for design, if the body is now expanded because we're vectors for microbes and we're transmitting microbes everywhere, then the protocols for how we inhabit space and what the good occupancy of space is and what the rituals for hygiene, health, and self-care are become altered by this. And so there's one aspect of the work that I'm doing, which is trying to think about how we get off fossil fuels by looking at living microorganisms and the incredible processes that they are capable of performing. The other part is looking at and what are the consequences of that in the rituals of daily life. I mean, what does it mean if we have a system in our home that replaces our boilers that's just digesting? What is the health risk to us? Does it become a companion? Is it something that we feed and care for and get to know? So once you start to think of elements of your daily life as having inner agency, maybe a certain kind of status, and therefore a duty of care to, it certainly shapes the idea that, we can just turn something on and off and then forget about it, which was a great convenience of modernity, but it came at a price.
Sure,
And
absolutely.
so it's about re-navigating, the trade-offs and the benefits of those things, I think is really part of this journey.
You have written that thinking about architecture as something that radically isolates us from the world, ecological systems, doesn't make any sense. So keeping that in mind, and this rituals, altered rituals of living that you just referred to, let's run a hypothetical here. If you were to be running our response for COVID, to the virus, or through your perspective, assume future technologies in place or whatever you want, how would an altered way be to respond to uh, uh, what we are calling a pandemic? What are your thinkings about that?
Right. So the first thing I would say is that you cannot extract the body from out of the equation. So the things that we are doing right now, which are self-isolation, washing our hands, all that, let's call it good maintenance of our microbiomes. So it's not just the bacteria taking care of themselves and these, the viromes in which we are immersed, that we have a duty of vigilance and care, both as individual people, but also as a community and society. So there is one thing about the bodily rituals, but then there's something about the spaces in which we inhabit. And the things that we don't know yet are what kinds of surfaces, what kinds of ventilation systems, what levels of humidity, what kinds of textures in our living spaces can really shape the distribution of microbiomes. So, for example, in an ordinary living room, most of your microbes will be on the carpet. Many of them will be on the wall. A few of them will be on the ceiling because they're driven by gravity. A lot of them will be around the sink on the sponge because they thrive in the wetness and the air and kind of good breeding conditions around the sink. And so we kind of know some of the spatial conditions. The kinds of questions you're hearing from the news right now is, do metal surfaces kill viruses after X number of hours and therefore render them safe? So I think we're going to see more of the spatial distribution of particular kinds of materials, rather than, let's call it, loads of hand cleaner and, kind of excessive amounts of toxins. And we're going to actually use changing our ventilation systems, changing our surfaces, thinking about the humidity of spaces, not just through these giant systems that, puff air into our living spaces, but maybe as a micro apparatus, within key living spaces in the house, bathrooms and kitchens and maybe even bedrooms. So I think there is in terms of design, we'll be thinking about, what cloths, what fabrics are actually really antimicrobial or attract the right kinds of microbes. So we'll be looking at probiotic spaces. We don't know what the relationship between viruses and bacteria are, for example, because bacteria, they've had a long-standing relationship with viruses and they're crafty. And so they have this kind of dueling relationship. Viruses confer some benefits, but on the other hand, if they take them over, they exploit them. So the bacteria will actually also maybe end up as being a first level immune system for us in contaminated spaces if we have the right microbes. But these are many questions that we haven't answered yet, and I think it's a really exciting realm for design, because we have to resolve the nanoscale with the scale of the human and the scale of a building, which I think is incredibly challenging. But I think it's the space that we'll be heading, I think.
Fantastic. I really love this notion of probiotic homes and probiotic clothing and probiotic living. Thinking of basically everything as probiotic would be my hope for the takeaway, that perhaps we would have building codes and theses on ways of living which would encourage probiotic thinking. So it's not just having your yogurt and doing your yoga, but actually, learning what your house is as a probiotic system. Sounds so fantastic. It's so much more advanced than just talking about passive and active systems. It sounds quite amazing. Has anybody actually started to write? Is this a term already? Probiotic architecture, probiotic homes?
I think it's a term that will probably be emerging if it hasn't already emerged, because the
Let's
University of
start the
Oregon.
rumor right now. Let's say it exists now.
It exists now, yes.
Very exciting. I love it. So one of the things I think somebody in your group, I'm not sure if it's you who has done this, is take on the topic of clothes. Yeah, fashion. And thinking of everything that we do, not just the utensils, but the home, thinking of materials that we use for fashion and how we wear clothes as also part of this probiotic living. Can you talk, would you be interested in talking a little bit more about that?
Well, I think at the moment, there is a great interest in thinking of more organic forms of producing clothing. So people like Suzanne Lee, she also has a TED talk online, which is looking at the bacterial teas and producing a kind of organic leather, the kombucha. Um, so there's an interest in these kinds of processes. And I think the difficulty in making the transition towards probiotic clothing has been really the complexity of the human microbiome, and how we can actually start to choreograph it, because I think we'll never control it as such.
No.
It's always going to be a negotiated relationship. But I think that shouldn't put us off from doing this. That we know that there's certain parts of our clothing that gets very sweaty, and that creates a certain kind of condition. There are also respiratory experts that are thinking about artificially introducing viral loads into home ventilation systems to prime young children's bodies against developing things like asthma. So I'm imagining also that, our clothing and, the things that are very close to us will help almost be like a vaccine, help us expose us to the right kinds of antigens. So, maybe fabrics, rather than, let's say, trying to control every degree of the microbiome, might be provoking particular kinds of immune responses and training our bodies up for healthier lives in, let's say, an increasingly complex world.
Mhm. Growing up in India, there's this sort of cliche that goes around with kids who grow up in third world countries have the advantage of a better immune system simply because you have been exposed to more microbes and been through a lot. And so, what that provokes me to think about is conceptually, just at a philosophical level, would your approach to dealing with the virus be more inclined towards simply kind of wading through it and producing what they're calling group immunity rather than radically trying to isolate it?
This is a deeply ethical question, and I think the simple answer to it is we don't know enough about the virus to say that things like herd immunity would not have terribly negative consequences for certain groups of people. So the ethical position is not to do that, and to try to break the chain of transmission as the first line action. But if we were talking about if we wanted to protect children against asthma and some of the allergic kinds of diseases like hay fever, then we do know a lot about how the kind of agents work on the body, and we can actually take a much more measured and responsible approach. I think the difficulty with the current pandemic is the uncertainty, and it would not be ethical to take the risk for even one person's death for the sake of a philosophy. So that's where I would, let's say, stand back and say there are certain things that we're learning how to do with manipulating microbiomes, and there's certain things, that we need to learn an awful lot more about. So I think that, from a responsible human kind of perspective, I think we do need to keep in mind just how much we don't know about the microbial realm, but that shouldn't put us off from measured experiment and considered choices about the way we live.
Right. I would agree with you completely. So as we move towards the end over here, I can't. I'm drawn in to again returning back to the quotation that I started with from your book. You say that experimental architecture's research methods share more in common with surrealism than industrial machines, and have more in common with things like Dali's soft clocks, hairy materials, liquid environments, and what most interests me, quantum phenomena. So surrealism and quantum physics, quantum uncertainty, let's just say. Would you unpack that for us? Tell us a little bit about why this thinking is surreal or quantum.
Right. So I like the definition of surrealism in that it is above the real. And when you look at life, it is a non-classical phenomenon. So for example, the idea that it works to reduce entropy. So it reduced, Schrodinger's notion that
Mhm.
life was something that reduced entropy. So it got rid of disorder in the system. Eventually, it lost the battle, but it's working against classical notions of material order. So surrealism in that sense, or the surreal, to me better describes life than our let's say Cartesian mechanistic models of the way that we narrativize the living world. But then also, the surrealists had a big obsession with quantum physicists and ideas
They
about
did?
chance. Oh, yeah.
Ah, ah,
Dali was painting a lot of quantum physicists in the last part of his kind of artistic career.
ah.
So, and and so even Duchamp is also kind of fascinated by the developments of science and technology at the time. So the quantum realm is of great interest to the surrealists, but also kind of picking up on, let's call it, the advances, again, late 20th century biology. The idea of quantum biology is now something that is still controversial, but is becoming increasingly engaged by the biological community. And that is really the recognition of some of these kind of non-classical properties of the living realm are being found to be quantum. So, for example, the European robin can navigate magnetic fields that are really tiny because of quantum entanglement that happens in its eyes. And also, if you
Really?
think about it,
Wow.
yeah. And also, if you think about it, plants are really weird. They're doing a chemistry that's like the wrong way round. They're taking ephemeral substances and they're turning it into matter. And so we shouldn't be surprised that actually photosynthesis itself uses quantum tunneling for molecules to be able to cheat and skip having to go through activation thresholds. So they can cheat the laws of chemistry by using quantum tunneling, and plants do that all the time. So there are new narratives that are developing about the living realm, and I think we need to, let's say, reorient our thinking about the potential of life, the strangeness of the living world, how it is non-classical, and think about how we work that into design. So this is where the alliance with surrealism would come from. And when we look at the kinds of materials that the living world works with, it is these kind of impossible things like soft structures and hairs and these kinds of intricate molecular dances that somehow or other against the odds hold themselves together. So I kind of delight in the almost magical qualities that the living world holds, including things like the idea of the soul. I think is something that we shouldn't lose track of, whilst we look to reductionist explanations for the way things work. I don't think that everything can be reduced into linear or classical causalities. And so it introduces this idea that there is something beyond pure or mere matter that we still haven't really engaged with in terms of our present narratives about the living world, and is something that I think that really should come back into play, particularly when we're invoking a re-enlivening of our planet. I mean, I think it's our moral duty to think of ways to inhabit and make spaces that contribute to planetary enlivening.
Yeah. And so, do you think, just purely speculatively, some reading of soul? You think the soul is possibly a kind of quantum tunneling, as in the flower?
I think it's a state. It's a state of an energetic state, I think. And the reason I don't really want to reduce it to that, but the thing that I've really liked recently, I've been reading about kind of electrochemistry, and that one of the simplest definitions of life is simply the flow of electrons, continual flow of electrons through matter. And so if you think about every single organic system, it stays in this living state because it's engaged in electron transfer. And you have two types. You can either do it through ions, which are much slower, or you can do it through fast systems, which are these transfer of electrons across loads of membranes. And we've kind of got loads of apparatuses and materials and systems. I mean, the inventiveness to keep these electrons moving is absolutely incredible. So at a very simple way, we could say it's a continual flow of electrons through a body, but also the electrons being quantum phenomena because they are less than an atom. So that there is a strangeness, I think, that happens once we start to get bioelectricity as opposed to industrial scale electricity. In other words, we're crowding all our marvelous electrons into a pipe and we're stopping them from doing magical things because we've just crushed them up so much, and we're telling them all you've got to do is give us power. But if we look at the way that biology uses electricity, it's incredible. It's so versatile. So I think that there is knowledge, and I think there is a kind of receptivity for, let's say, retelling the stories of life through some of the new insights that we've had, particularly late 20th century, but I think throughout the 20th century as well, we've had very fixed ideas about the order of things, and I think we've let that shape our expectations.
It reminds me of Michael Pollan's book, How to Expand Your Mind. I'm not sure if you run into that.
No.
He's a fantastic writer, and The Botany of Desire was his well-known book, but his recent book is actually on psychedelics, and he talks about how everything is alive, everything has consciousness.
Wow.
It sort of connects gesturally to what you're talking about, because if you think of, I don't know how the discussion moved to electrons, so bio moving of electrons.
Yeah.
But it seemed to suggest to me that everything has a kind of consciousness like we do, which would suggest that the soulness of things is an omnipresent quality rather than something very anthro-specific.
I agree. I think there is a nascent vitality that's present on this planet that we don't know exists anywhere else. And it was also said, by people like Lynn Margulis, that life may have been extinguished on this planet many times during the Hadean bombardment when all the asteroids crashed into the planet, and so it was kind of knocked off many times. But there's something about the way that our planet is configured, its weird chemistry, its restlessness. It has tectonic plates and magnetic fields and solar winds, and these incredible things. It's like a big cauldron, and there's something about those conditions that has been responsible for this weirdness, and whether this weirdness can persist beyond these conditions, I think, is something that is yet to be seen.
Oh, so this is your interest in the origin of life sciences,
right?
That you've been reading. Fantastic. We'll have to come back and have another discussion all on that topic if you're willing.
Fantastic. I'd love it.
Well, thank you for this particular discussion. This has been so amazing. I will look forward to speaking with you again. Thank you, Rachel.
It's been a lot of fun. Thank you so much for inviting me onto your program.
Thank you for listening to Architecture Talk. This is your producer, Amelia Jarvinen. We hope you enjoyed the conversation, and if you did, please subscribe and rate us on iTunes or Spotify. We would also love to hear from you if you have any suggestions on new topics or guests. You can always reach out to us on our website, Facebook, or Instagram. Thank you again, and until next time, this is Architecture Talk.